It worked.
Woohoo!
Hey everybody. So my name is Derek Wheatcroft. I'm the practice lead here in San Diego at Slalom. Been at Slalom about 8 years, and we're here to talk a little bit about what we do with Google Cloud. This is Stephen Nichols.
I'm a solution architect with Slalom, and I'm kind of leading up the Google Cloud practice.
Yeah, so we've been to a couple clients with Chelsea here locally in San Diego, so she asked us to come out and talk a little bit about our services.
Only thing that's
I know, right? So I dragged Edgar here with me and Stefanos. So if you guys have any big data, Google Cloud, any of those kind of questions, you've seen their faces now. Now you know who to pick. Real quick, who's Google? So we're about a 5,000 person consulting firm nationally. We've got an office in every city where there's a major football team. We consistently win best places to work on Glassdoor and Equality Index and Fortune and all those fun places. So we're kind of an unknown entity here in San Diego, unfortunately. So we're going to events like this to try to get our name out there a little bit more. So I head up our technology enablement practice. That kind of covers 4 main areas: traditional software dev, digital experience management, cloud, which we're here to talk about tonight, and then DevOps. So a little bit about our team. Everybody we hire either has a consulting background or is a deep technologist. You know, hands on keyboard. We don't hire any PowerPoint architects or anything like that. Everybody's DevOps, kind of cloud first. We have partnerships in all 3 cloud providers, although Google's obviously our favorite right now. Always. And I have to say that. Who are all sorts of services? Yeah, exactly.
Some small guys.
Yeah. So we do all the traditional services that you can imagine. Big companies are asking for. You have these big IT shops with thousands of servers and hundreds of applications. They say, "What in the world can we do in the cloud?" We tell them everything. We can migrate. We can help you architect. If it's HIPAA compliant data, we can help you get over that hurdle. We can help you operationalize it. We'll do workshops with operations teams. We'll do greenfield dev. Whatever you need, we can help you out with. From a partnership perspective, we're approaching 50 certifications from our technologists, and that's kind of split between the 2 main areas, the data engineer and the cloud architect. We have competencies in everything Google offers partnership competencies in. We're a premier partner status. We have just under 30 local cloud architects and engineers. We're nearing 100 certifications. I'm going to be really happy to hit that. Here's the NASCAR slide. If you have any questions about what we're doing in any of these accounts, let me know. And I'll let Stephen cover a little bit of kind of the offerings that we'll have.
So, I mean, I won't exhaust this slide, but really what we want to show is we go from cloud strategy all the way to low-level implementation. So if you know exactly what you want and you need some engineering work, we're there. If you have no idea what you want, but your CEO is saying, we're not in the cloud 8 years ago, what's wrong with you guys? We can help with that too. And kind of all the way along the line. So we've seen some companies have the burning data center and they get into the cloud and then it sucks because they didn't do it right. And suddenly their OpEx cost is 10 times what they're spending before, and we can help them fix that. So we really incorporate DevOps and all those nice fun buzzwords that go along with cloud into things that we do today. And then one thing some of the stuff that's not on this slide is the big data analytics work. So I'm going to point out Stefanos over there. He's from the team that does it. So, obviously Google's the leader in their whole suite of data products are just out of this world, I know. So we get a lot of work through that, and actually that's a lot of the area that we see Google come first. So we really do a lot of work in that area too. It's not up on the slide.
Cool. If you have any questions, feel free to yell at us or grab a beer with us after, or say, "Hey, you okay?" Awesome. Thanks, guys.
Are you guys local? How many of you are local here in San Diego, Orange County?
So we have 27 between Orange County and San Diego. It's about a 60-40 split. So I would say, maybe 12 of us are down here in San Diego. We got San Marcos, Torrey Pines, Normal Heights, still Orange County. I'm going to get you to move down here. But yeah, we've got a good presence down here as well.
And that's our technology practice. Our whole office is in Irvine. I think it's about 150 people for now.
Yeah, so we do digital experience management, information management, analytics, strategy, ops, like your traditional full suite consulting firm. So we just represent the techies. Cool. Thanks.
Woohoo!
Let's see here. I'm not sure why this one is inverted now. Very strange. Inverted here was not that. Okay, on this side. Yeah, I think on this side, if you could just kind of turn, look up, it'd be great. So hi, my name is Stuart Runyon. I'm the Vice President of Engineering at Zesta.io. So first, a little bit about Zesta.io. We're a software as a service company who provide a web content management system for our customers. So what that means is we make delivering enterprise-grade websites and content easy. Our platform provides scale, security, and a CMS your marketing team won't hate out of the box. This empowers our customers to improve their end users' web experience, make their marketing team happy, and free up the development team to be more agile and focused on building experiences, all the while staying compliant with their departments. So today I'm going to share some insights into kind of how we deliver on the scale and stability of our platform. I'll start with covering how we got to our current architecture. Then I'll share some ways we've been using Stackdriver. Then finally, I'll cover the core value. They cover the values this has provided our business and customers. We will also have some Q&A time after to kind of dig deeper into these topics. So first, to give you some context into the level of traffic we deal with at Zesta.io. In the last 30 days, our platform saw close to 500 million requests that equates to approximately 72 terabytes of data. And as this graphic shows, we have had a significant increase year over year. And some acronyms for those who are unfamiliar. So we have GCP, which is the Google Cloud Platform. This is Google's suite of cloud-based services. We have GKE, which is Google Kubernetes Engine. Then we have GCE, Google Container Engine. These are two products offered within GCP. Then we have GAE, which is Google App Engine. Essentially, this is GKE and GCE as a service. We also have IaaS, Infrastructure as a Service, PaaS, Platform as a Service, and Max Monitoring as a Service. So some terms you probably may not have possibly heard before. So before we cover how Zesta.io uses Stackdriver, I'd like to tell the story of how we arrived at the current state of our platform infrastructure. So we have three primary concerns with our platform infrastructure. You may be familiar with some of these or all these. It wasn't too long ago that all these had to be solved in-house by our dev team. So the three concerns, we have hardware upgrades, server patches, and server outages. So hardware upgrades. That's generally, it's like we have a lot more customers now. Our server resources are getting maxed out. And how do we scale this? This traditionally used to be, you would have some sort of maintenance window. There'd be an actual physical hardware exchange. This is obviously, a very fragile kind of process. A lot of concerns, a lot of things that go wrong here. Then we have server patches. This is when you upgrade the operating system software or software your services depend upon. Same thing, a lot of concerns here. Is this going to break anything immediately? Will this break things later after I've updated these? If they do, how do I figure out that the update was the root cause? And then outages. So how do you know when your services are down? Hopefully you know before your customers call you. Once they are down, or if you're having issues, how do you recover from that? So first came IaaS. So infrastructure as a service takes a lot of the pain away from running servers. Specifically, it solves the hardware portion. Now when you want to upgrade your server hardware, there's no downtime. It's the push of a button, the slide of the scale, and in a few minutes you provision new, more powerful hardware. This is virtualized hardware.
It allows for vertical scaling of your resources. At Zesty.io, we originally ran within Rackspace, who was our infrastructure provider. They gave us servers we could scale with UI, but we still had to manage upgrading servers and ensuring they were alive and healthy. So you also have server patches. So a platform as a service is when both the hardware and the underlying operating system of your code base runs on is handled for you. So PaaS allows your software to be horizontally scalable, so we can add new instances with a click of a button. At Zesty, once we decided to move out of Rackspace, we began evaluating what the next evolution of the platform would be. We considered AWS and deploying our service with like golden server images, via CI/CD tool, to the point of we built a CI/CD tool. Although fun, I would highly recommend you not build your own CI/CD tool. Also, PaaS wasn't quite a proven delivery model or business model at the time we were looking. Heroku was the primary option, but it was cost prohibitive with the amount of traffic we served. Eventually, we settled on running Docker containers within a Kubernetes cluster in GCP. Essentially, Kubernetes provides the tooling to run your own patchable and scalable platform without a service provider. We selected GCP over AWS as our vendor due to Google's experience delivering services with Kubernetes, and because at the time, AWS Kubernetes support was pretty terrible. So then finally, we have MAS, monitoring as a service. So monitoring as a service handles our final concern of how do we know our services are running and healthy. You've probably heard of services like Pingdom, whose products ensure these things for you. Monitoring as a service typically works by making HTTP requests to your services and sends you an alert if they do not respond within like a certain defined time limit. Although we had Pingdom and log ingestion in place, we were not capturing metrics on our services. We considered setting up a Prometheus.io server and instrumenting our code to collect those metrics and send them in to that server to report on this. I'm very glad we did not. As we found out, Stackdriver can provide virtual machine and networking metrics out of the box. Plus, I'm pretty sure Stackdriver actually uses Prometheus under the hood. So, done for us. Stackdriver. So with GCP, specifically GKE and GCE, we solved two of our primary server concerns. For our third concern, we were able to significantly improve this by taking advantage of Stackdriver and the integrations it has with GCP. So, Stackdriver day one, we get quite a few things out of the box. We get metrics, policies and alerts, uptime checks, and graphs. So with the metrics, I would say arguably this is the biggest value provided by Stackdriver on day one at no organizational cost. So what do I mean by no organizational cost? Two things. There's no need to hire someone to accomplish this. And two, there's no development work needed to be completed before you get this value. So we also have policies and alerts. Policies and alerts give us good insight into when our platform is exceeding its standard usage, allowing predictions of outages and circumventing them before they occur. It also allows for immediate response times from our developer teams when incidents do occur. Then we also have uptime checks. So our uptime checks help us do health checks against our platform and our core services. We have health checks against our customers and their services. So basically, anything available via HTTP is checkable. And then graphs, sweet graphs. So the graphs allow us to explore our data, to discover areas which need investigation. They also allow us to view our data over time and discover trends, whether those trends are positive or negative. Yes. Finally, to the graph portion. That's what we all really want to see. So policies and alerts. So in this graph here, we are setting up an alert for CPU usage. If our VMs exceed 80% usage over 10 minutes. Now, I would not encourage you to go and set this up for an alert for a production environment. You're going to make your developers very mad and very tired. We drove ourselves a little crazy for a few days while we debugged some of our services with this alert. But it was very helpful in debugging an issue we'll look at in just a few slides here. So, uptime checks. So by adding uptime checks across all available regions for our customers and product endpoints, we were able to gain insight into our global latency performance. As you can see in this graph, we have a huge spike in latency. Now, I assure you this is not as bad as it looks. But what it allowed us to do was, once we investigated, we were able to determine it was a single uptime check location that was experiencing latency. So it usually typically indicates there's an issue with the check at that point in time, not the platform. But it's nice, it kind of gives us that peace of mind of, oh, something may have happened here, let me look. Oh wait, no, it's fine, it's a single location, move on. But it's amazing, so out of the box I can monitor multiple uptime checks and have an alert if multiple regions and multiple customers experience latency above a defined threshold. Then our development team can receive a notification allowing them to respond to a potential issue immediately. This is awesome. So, graphs. So now here's where we were able to kind of get some insight into our, via our CPU alert there. So our alert exposed a large issue that once we resolved, improved our platform stability significantly. So as you can see from this graph here, we previously averaged a load of about 40%. And then suddenly we have this spike where we hit 100% CPU usage. Now, resource usage at 100% is not necessarily a bad thing. But what occurred was sustained usage, which maxed out our allotted Kubernetes cluster resources. So this graph is what gave us insight into otherwise just observing the effects of increased response latency. Insight is definitely the best way to put how metrics and monitoring can help your product or services. Do not expect answers. Instead, judge your graphs on by how well they point you in the direction to look. In this case, we were able to quickly identify the service using the most CPU resources and then dig into our code to determine how to optimize its resource usage. So as you can see here, right after that 100%, it gets kind of wonky. That's us making fixes. That's us coming down, and then at the tail end there, right, we've solved it. Right? We found out the solution, we've normalized our usage, and as you can see, we cut our usage in half. So this was huge. Now, Stackdriver can actually be used independently of the rest of Google Cloud, but there are quite a few benefits of combining the two, especially with Google Extension. Everything I've shown so far is data we currently have coming from a Kubernetes cluster in GCP. There's a lot of work to set that up, to maintain it, and build on it. This is where App Engine shows its value. It's essentially Kubernetes as a service. Our team doesn't have to deal with the details of how software gets put into the network and scaled. They simply define a container, a Docker file. They set up an app.yaml file, and then they just release application code. Fantastic. So what this means is our container orchestration plumbing, service resource scaling, and networking is done for us. And along with all of this, since App Engine is handling your Kubernetes cluster for you, they can make exposing your cluster and your container data dead simple, making the process of what I've shown today instant from day one. I mean, like literally the second you're running your platform in there, you can get all this data there with you. It's fantastic. So these value props from App Engine are so strong. At Zesty.io, we're committed to running our complete platform within App Engine. Although this equates to increased monthly costs for us, we believe it will result in reduced organizational costs in the long term. Fast and lean development, our favorite thing. Now that our three primary concerns of upgrading software, patching servers, and monitoring to understand outages are handled, what's left? Solving problems for your customers, obviously. So by solving these three concerns, an amazing thing happens. Your engineers can have confidence in their deploys. When they have confidence in their employees, they can iterate faster. When you're focusing on product and iterating faster, you allow your team to get closer to your customers' concerns, which creates a more customer-focused engineering culture. Plus, you can start doing some sophisticated things with your releases, which is pretty sweet. Such as, we have tagged canary releases with rollbacks on alerts, so you can watch your error count shoots up, roll back, something went bad. You can observe trends over time to find resource hot points. You can discover weaknesses in your architecture. And if that wasn't enough, you're not even ready for this next slide. You're not. GCP has customer service, what? Get out of here. So we made the switch to GCP 2 years ago. It was great. We got all the already mentioned benefits, but this was pre-Dan Green as Google Cloud's chief. And let me tell you, GCP with Diana Green is something special. The day we got a calendar invite from our account manager, which, by the way, we do not have an account manager, I knew we had made the right long-term choice. It's fantastic. So anyone who's worked with enterprise knows the need to provide services for complex and high-value customers. This aspect has really set GCP apart from your competitors. So how do you know that? The value of GCP for us is the integrated nature of their products and how that equates to a feeling that they're aligned with what we're trying to accomplish, building web-based services. Web-based services are naturally going to require some specific resources. For example, servers, caches, databases, queues, CDNs, networking, and a lot more. But instead of just giving you these raw resources and leaving it up to you to connect, manage, maintain them, they do all this for you, as well as send all the resource metrics that are generated into Stackdriver on day one. So you can have the monitoring you need to be confident your platform is healthy. This saves us a large amount of time. We're talking months instead of needing to build these solutions ourselves. So what I've shared tonight is just a small look into our continual journey of improving our platform architecture, getting deeper insights into our metrics, and how this translates to providing a stable and scalable platform, ultimately resulting in increased value for our customers. Thank you. Any questions? Yes.
Did you compare Stackdriver? And I'm not saying those tools are better. I'm just curious. But there's also Sysdig and Datadog, and they offer you monitoring as a service.
Yep.
And since you already implemented your monitoring, have you looked at Datadog or Sysdig?
Yeah, so I'll try to give like a fair representation of that. We definitely did. I definitely looked at Datadog. We already had like log ingestion happening. So I kind of like, that's where we were so tempted to go with Prometheus. It was like, oh, this shit's already here. Let's just type it over here and, you know, run some, you know, what's it, Kibana stack, or what's the Elk stack, thank you. And so it was just like, as a developer, you see, you're like, oh, just run an Elk stack. It's so simple, it's right there. But what actually happened was we experienced that spike, and we said, well, okay, let's figure out what's going on here. And then I was kind of clicking around. I was like, oh, man, this is here. And so I looked at Datadog. We've considered it. Like, we run, like, Bugsnag as well. But the fact that Stackdriver lives so close to GCP, and since we are, like, fully bought in to GCP, knowing that they're going to take that forward and improve it and kind of make that integration possibly tighter, that's what was kind of the big, like, okay, this is definitely where we want to go. I mean, to the point of, right now I'm trying to figure out, like, how do I replace Pingdom? How do I reduce that cost? How do I, any service that I can drop and replace with this, I'm trying to figure out how that works. Cool. Any other questions? Aaron?
What you said with Docker, Kubernetes, and the YAML files and kind of setting that up, is there a good documentation of where to first try to do that or how to learn how to do that?
Yeah. As far as the container goes, there is Docker. Docker has very good documentation on I would say the APIs and kind of configurations available. But they don't exactly tell you kind of the path forward. Like you really have to understand like what are the things I need on my operating system? What are the dependencies I'm trying to accomplish within this container? And there's definitely some trial and error figuring out how all these pieces fit together. But then as far as like the app YAML stuff, that's documented very well. It's also very straightforward, which is, it's super weird too how the complexity level of using a Kubernetes like deployment YAML versus the app YAML, it's like almost like an order of magnitude where Kubernetes feels simple. It is conceptually simple, but executing on it is not so much. Whereas with App Engine, there is no execution. It is simple. You just define your app YAML and send it in and boom, your services up. You don't have to think about the rest, which is pretty nice. Yes, Vinay.
So what are you doing for international clients that are in China or somewhere where GCP obviously isn't available?
Yeah, so we actually, our primary global distribution is done via CDNs. So that's where a lot of the requests get serviced from. Which is actually so it's kind of rabbit hole here. That spike I'm trying to dig into and working with Chelsea kind of figure it out. When I think through it, I start to go, okay, well, this is weird because the uptime check is showing latency, but that uptime check is obviously hitting a CDN pop. So is it the check? Is it the pop? Is it something in between? Is it the origin? So yeah. But yeah, for globally, we service our global customers via CDNs. Cool. Any other questions? Awesome. Oh, yeah.
Have you done any, actually I have two, so are you using App Engine in custom code instead of just using Flex App and Docker? And then have you done any custom Stackdriver plugins?
There are custom Stackdriver plugins? What? Oh, shit! Well, I'll be up tonight. I have not touched on custom Stackdriver plugins. So for us, so we're currently kind of in the pipeline of going from our GCP cluster into App Engine, which when you're in Origin, let me tell you, is a nightmare of figuring out routing and networking, how that all works out. But basically, we're sort of splitting off services into our App Engine environment. I played around with so we're also in the middle of, as we do this, we're rewriting services. So we're going from PHP to Golang. Our Golang services, we played around with initially in the, it's called standard. Yeah, so App Engine standard. I was not satisfied with that. It's definitely something we'll consider for our probably very core services where we just need like insane performance. But the way we kind of architect our platform, we add a bunch of stopgaps before kind of the compute runs down all the way to us. So we run App Engine Flex with actual Docker builds. We were previously running the Go environment. Yeah, we were running Go environment in Flex, but we wanted to be able to have our Docker containers run our developers' local machines and use Docker Compose to orchestrate all that. So now everything's inside of a Docker container, and we're running Flex in custom. Yeah.
What do you guys do for local environment? How your developers test locally?
Yeah, so our developers run the whole stack locally. We built that initially when we migrated into GCP using Kubernetes. And so we run Docker Compose just because Minikube wasn't kind of up to snuff at the time. And so everything's wrapped up in a container, Docker Compose, with Docker Compose YAML, which ties everything together for all the services. Works out pretty well. It's definitely, I mean, we run a lot of services, so it's complex. But for the amount of services we run, it's pretty amazing what we're able to do. I definitely want to kind of check out Minikube and maybe migrate from Docker Compose to Minikube for local stuff. Yes, sir.
Are Have you guys used any of the GCP services?
Oh yeah. We use Cloud SQL. Yeah.
Cloud storage.
Oh yeah. Oh, dude, our GCS, our Google Cloud Storage is insane. The way we handle servicing our media is a whole nother topic. So yeah, we use Google Cloud Storages. We use SQL. I think that's it. BigQuery, yeah, we're doing all our reporting off of BigQuery.
Check out telemetry, and then telemetry will allow you to run local copies of some of your services while the rest is running remotely, and then you don't need to run mini.
Okay. We actually, so that's part of our GAE switch we're doing is we're moving, whereas previously we had databases we can run locally, we're moving those into the cloud and having those all be run. Final offer. Any other questions? All right, well, thank you for coming.
Well, feel free to grab any food on your way out or stop, talk, take your time. If you have any questions, feel free to reach out to your local account team, which is half me, since I'm one of the only ones here. But no, we want to get this going, so we'll do one on TensorFlow next month. We'll send out some more information on that, and if there's anything, other topics you'd like to see, let us know, and we'll see what we can get set up. Thanks for coming.
Thank you.
Thank you.